Hi, welcome to Beginning Engineers. Today I'm going to be talking about chemicals. They're everywhere in manufacturing. What are chemicals, and why do they matter? If you're like me, you might have been bad at chemistry in high school and college, but trust me, as an engineer, having a basic understanding of chemistry and chemicals is pretty important. In their purest form, chemicals are chemical substances, matter consisting of the same type of molecule. A molecule is two or more atoms held together by chemical bonds. These molecules in the same structure makes a chemical substance. They cannot be separated by usual physical forces. So in this way, they are kind of like nature's most efficient assemblies. Generally in industry, when discussing chemicals, you are usually discussing a chemical compound. A pure chemical compound is a chemical substance that is composed of a particular set of molecules or ions. Two or more elements combined into one substance through a chemical reaction form a chemical compound. All compounds are substances, but not all substances are compounds. Let's go back to basics with chemistry. Let's review the fundamental elements, the periodic table of elements. All matter is made from elements, and all elements are contained in the periodic table of elements. All those elements still discovered. The fun thing about the periodic table is that it's still expanding. There's elements that are theorized, but until we make them, until we can observe they actually exist, they're not on the table yet. And I know something that wasn't really stressed to me until high school that I think is really important is that there's an order to the periodic table. There's relationships in the table. The rows and the columns have relationships. Groups are what you call the columns in the table, and they share a relationship if they're in the same column. Periods are the rows in the periodic table, and if you're in the same row, the same period as another element, you share some characteristics with it. For example, the first column in the periodic table, the first group, is known as the Alkali Metals Group. These elements are typically shiny, soft, and highly reactive due to just a single electron in their outermost shell. As you go from left to right in the periodic table, more and more electrons are added to the elements. And elements have different shells with different configurations, so electrons group in certain ways. And for this first group, the Alkali Metals Group, there's just a single electron in the outermost shell, making it a very reactive element. Alkali metals want to give up that electron to become more stable. Alkali metals elements are useful in batteries, like lithium ion. Lithium is an alkali metal. They're useful in warfare. Sodium nitrate is in gunpowder. Sodium's an alkali metal. They're useful in fertilizers. Potassium's an alkali metal. Another example of a group in the periodic table of elements is the noble gases group. This is kind of like the polar opposite of the alkali metals group. They're odorless, colorless, and very stable due to not wanting any more electrons. Whereas your alkali metals wanted to give up an electron, your noble gases have a full outer shell. They really want to keep things the way they are. Noble gases are used as a coolant in MRI machines, that'd be helium. They're used in light bulbs, argon mixed with nitrogen, to prevent the filament in a light bulb from burning away if there was just oxygen in there with it. So beyond the manufacturing usefulness of chemicals, a lot of the fun in chemistry happens when chemical reactions occur. A chemical reaction is when one set of chemical substances, called reactants or agents when reacting, transforms into another, typically by the loss or addition of electrons. This involves the breaking of chemical bonds. So when those alkali metals give up that electron like they want to, a chemical reaction is happening. With chemical reactions, there are four main types. Synthesis. This is when two or more substances combine into a more complex substance. I feel like this is the one you hear about the most often when hearing about chemical reactions, or some crazy movie, someone will say, I've synthesized a new chemical. Well, they're combining two or more things into a more complex thing. You have decomposition. This is basically the opposite, a complex substance breaking down into more simple components. You have single replacement, which I think is best illustrated by my example in the parentheses. This is when an element trades places with another that was in a component. So literally, you have element A plus compound BC, and then after your chemical reaction, you have element B by itself, and elements A and C in a compound, so they literally trade spots. Elements A and B traded places. Then you have double replacement. This is when elements in two compounds, so not just an element and a compound, two different compounds, switch places and form entirely different compounds. So elements AB in a compound plus CD become AD plus CB. So we have two compounds in the beginning and two completely different compounds in the end. So we've talked about elements, we've talked about compounds and what a chemical is, but what are some of the more common chemicals that you might actually interact with in the world? Well, chances are, if you interact with a chemical in the real world, or work somewhere that makes one, it might be one of these five. Sulfuric acid, that's H2SO4. This is the most produced chemical worldwide. It's used in fertilizers, detergents, batteries, and more. You have nitrogen, two of them to be precise, used in the production of steels and other metals. Also very efficient as a cooling substance. Ethylene, that's C2H4. This produces synthetic rubber, among other items. Gee, I wonder where we see rubber on a daily basis. Cars, shoes, and many others. Oxygen, O2, just like nitrogen was N2. This is used in items like welding torches and rockets. If you want to go to space, you're probably going to use oxygen. Chlorine, that's Cl2, used as an antiseptic and in the production of paper, among other things. If you ever swam in a public pool, chlorine's involved. Beyond some of the most common chemicals, what are some common chemicals in manufacturing? So if you're working in manufacturing or a similar industry, here are some chemicals that you may interact with. Acetone. This was one I worked with a decent amount. It's a colorless liquid typically used for cleaning. It's CH3, two of them to be precise, and then CO. Then you have caustic soda. This is also known as sodium hydroxide, Na sodium OH. This is used primarily for cleaning and papermaking. It helps with color changing and brightness. It's one of the most widely used alkalis. Alkali is a chemical compound that neutralizes or effervesces with acid and turns litmus blue. So on the acidic scale, it's the opposite direction from acid. When I was in school for engineering, I did a product at a papermaking facility, where I would walk around and map out their caustic soda pipes. So pipes that would transport their sodium hydroxide to different stations, just to identify things like leaks and other items like that. Because, as I'll touch on later, it's very important to know the hazards of the chemicals you are using. And finally, a chemical that's very common in industry, lubricants. Used to reduce friction in assemblies, machinery, so many uses for lubricants. Lubricants are typically made from petroleum, which contains a variety of hydrocarbons, a compound of hydrogen and carbon. So you'll see there I have a little graphic on composition by weight, and you'll notice that carbon at 83 to 85% and hydrogen at 10 to 14% are the main two elements you'll see in petroleum. But you'll notice there's some other elements as well: nitrogen, oxygen, sulfur, metals. So there are other elements you'll see in petroleum, but typically you're talking hydrogen and carbon. Alright, let's talk safety. I have a safety video where I go into more detail about this diamond, but I think it's important to touch on here because if you're talking chemicals, you have to know how to handle them and how dangerous they can be. So remember, the NFPA diamond, the NFPA diamond, your guide to how cautious to be with a certain chemical. This is a standard from the National Fire Protection Agency, so that's the NFPA. People call it the fire diamond. You'll see it on tanker trucks, barrels. Chances are, even if you're not working in industry, you've seen this before. But maybe you didn't know what it meant. Well, let's talk about what it means. There's 4 areas on the fire diamond, and each one is on a 0 to 4 scale, except for the white one, which gives you special or miscellaneous information, like this chemical is an oxidizer, or it will react with water, or sometimes you'll even see symbols of protective gear to wear around that chemical when handling it. If you don't have the proper PPE, personal protective equipment, you shouldn't be handling that chemical. But the other 3 are 0 to 4, and it's a scale for how dangerous they are in that relative area. Red is flammability, so a 0, it's not going to catch fire. A 4, it can catch fire very easily. At room temperature likely. It has a low flash point. There's more specifics on how something gets a rating, but just knowing it's a 0 to 4 scale, with 4 being the most dangerous and 0 being not a hazard in that area at all, is pretty good overview of the fire diamond. You have blue for health. So this would be how bad exposure would hurt you. Say you spilled a little bit on your skin. So a 4 would be something where even if it's on you for just a little bit, it poses a very high risk to your health. A 0 would be something you could spill on yourself and you'd be fine. Maybe it dries out the skin a little bit, but it's not much of a hazard. Yellow is how unstable something is, how easily it reacts with other chemicals. So a 0 in the yellow category, in the instability reactivity category, would mean it's not going to react with water, it's not going to react if there's a fire around, whereas a 4, that chemical is super unstable. Maybe you put some water on it and it explodes in your face. Or there's a fire that starts nearby and all of a sudden this chemical is giving off a toxic fume. Sometimes you need more than just how hazardous is this chemical, and that's where safety data sheets come in. I think I'm going to do a full video on these, but this will just be a brief overview. Safety data sheets are part of the global standard for how to define a chemical. It's part of the globally harmonized system of classification and labeling of chemicals. And the United States uses safety data sheets now. They used to be called material safety data sheets, MSDS, in the United States, but sometimes you would find problems between different companies where things would be in different positions. So one of the big benefits of the safety data sheet that many countries have adopted is that it sets a strict hierarchy for what goes in what section. So there's 16 sections and they describe various items about the chemical. And here's an example of a few of the sections. Composition, company that made it, and what you would typically use it for. You have hazards, so this overlaps the NFPA fire diamond a little bit. First aid and firefighting measures. So the NFPA Diamond will just tell you how hazardous it is. It won't give you any first aid advice. So you can see where a safety data sheet would be a lot more beneficial to have on hand. In addition, a safety data sheet will tell you how to handle and store that material for long-term use. One section is stability and reactivity. So that again is like the fire diamond, but it's going to go into more detail. And then there's many other sections, so 16 total sections. Usually a safety data sheet for a chemical will be multiple pages. And finally, now that we have an overview of chemicals and how they're involved in the world of manufacturing, let's focus a bit on what your chemical engineering coworkers or chemist coworkers do with their jobs. The biggest thing that chemical engineers specifically do is design and develop chemical manufacturing processes for a variety of industries. Pharmaceutical companies, food industry, chemical production, paper production, synthetic fibers, waste disposal. Think about everything you do in your daily life. You throw away food, you eat food, you take medicine to feel better, you wear clothes, at work you print on paper. All those things involve chemicals. You don't get to wear that high-tech rain jacket or eat that delicious frozen meal without some sort of chemical engineer being involved in the process to make that item, because that item took some sort of chemical to make. Even if at the most basic level it was just some lubricants and cleaners that the machines needed, chemical engineers at some point were involved with that. And a lot of chemical engineers just start in general process development anyway. So if you're an industrial engineer or a quality engineer, you might be working with someone whose background is chemical engineering. Because even though chemistry gets very complicated, having a good feel for process development and control is a good basis for a chemical engineer to have. A friend of mine who is a chemical engineer, she worked at the Honda Marysville assembly plant in Ohio. She started out in quality, and then eventually through promotions, she would be able to work with chemicals had she stayed at that job. Once chemical engineers or chemists, or even someone in the field starts working with chemicals, they're probably testing chemical mixtures, determining overall quality percentages, and analyzing hazard risks in laboratories. These are more hands-on with the chemicals used in manufacturing. Thank you so much for watching this video. I hope after this video you now have a decent understanding of what chemicals are at the most basic level, why they're important, what they can be used for in manufacturing, some common ones you might interact with, how to be safe with chemicals, and in general, what are your chemical engineering coworkers doing with their days? If you like this video, feel free to subscribe.